Hmm. Hello, friends. Hmm. Oh, you unavailable? Oh no. Go to switch account. I'm going to switch to wake up and think clearly. There we go. Philosophy of logics. Okay, it's working. So there I am. So it's Sunday, the 7th of January. It's 2:19 in the afternoon. Oh, let me put this on. Okay, so let's study the philosophy of logics. This is a useful, stimulating, reliably informative, and enjoyable. By Susan Hack. Hack. Let's see. So Hack discusses the scope and purpose of logic, validity, truth functions, quantification, and ontology, names, descriptions, truth bearers, set theoretical and semantic paradoxes, and modality. She also explores the motivations for a whole range of non-classical systems of logic, including many-valued logics, fuzzy logic, modal and tense logics, and relevance logics. So I read the list somewhat confusingly. So one item of several that are included in the non-classical systems of logic include the many-valued logics, the fuzzy logic, the modal intense logics, and the relevance logics. So I don't know anything about these logics. So logically, we should read from this book and learn about them. But we should come in knowing something about logic. We should have an elementary knowledge of formal logic. That I am deficient in also. We might need to go over some things. In logic, you may encounter some notations. So here's the notations that this book will employ. Let's see. Flip the camera and we get these. For example, A, comma, B, dot, dot, dot. I guess that's in capital letters. That's A, B, C, D, E. So those represent meta variables ranging over sentence letters. Now, sentence letters, they're labeled P, comma, Q, dot, 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 and they're lowercase. Now, let's consider this symbol, negation. That means it is not the case that blah, blah, blah. Well, in mathematics, there's a negation that makes a positive number negative. So it flips it over to the other side of the number line. This is maybe kind of like that, but not quite. And when you have truths, two truths, and you have true or not true as the final results. So if you take truth and put this symbol in front of truth, then you get negation of that truth. So you could read it as, it is not the case that truth, a statement of truth. So it is not the case that that statement of truth is true. With this symbol, negation. Then there's the symbol disjunction. So what is that? Oh, it's V for victory, and it means or. Disjunction, or sometimes called vel. In Boolean logic, it would be the or function. And that means that it could be one or the other or both. If there's two variables, I guess it would be that case. There's another one similar to or, but it's inclusive, right? Maybe. Is that the word? It's an and. So that's a conjunction. Conjunction, junction. And you say it out loud as and. And you can read it as ampersand, and that's what this is, an ampersand. But it means and or a conjunction of two or more items, and all those items are considered that means that in order for the sentence to be true, each item would have to be true. Like say if there's two items separated by an and, a conjunction, that means that, let's say the two items are labeled A and B. So with A and B, that means that both A and B must be true. If one of them is false, if one of them is not true, say A is true, but B is false, and you have and in between them, A and B, because B is false, then the result is that the combination is false. So that means that in order for the result, the end result of a conjunction to be true, the individuals have to be true. So that would work in the statement of a president must be 35 years or older and must be a citizen of the United States and have been born in the United States. So those three items are separated by and. So if one of them is false, like say he's less than 35 years old, say he's 34, then he cannot run for president and cannot be a president, even if the others are true, even if he's U.S. citizen and born in the U.S. That kind of thing is what you get with and. Yeah, I've learned that from studying digital logic, Boolean logic, and circuits, and a little bit of regular thought logic. So now what about this symbol? It looks like an arrow from left to right. It's shooting towards the right. So that means material implication. If so, I would probably use that in the beginning of a combination of sentences. Like say, if A and B are true, then something else is true. Here's another symbol. It's got 3 lines stacked on top of each other, and it's more than 2 lines. So 2 lines, I would mean it to be equals. With 3 lines, so what does that mean? Oh, it's kind of like equals. It means equivalence, material equivalence. That means if and only if. So it's a little bit stronger than if. If and only if. That suggests that it happens if and only if this happens. So that makes it equivalent. What is considered right after the if and only if statements? Those requirements it's so complete, the requirements, that it identifies the object. So the result is that the result is equal to the components, you could say. It's equivalent. Like one side of the equation is equal to the other side. It's a little bit different from just if. If perhaps is a way of showing dependency, that this effect depends on that. So it's suggesting that if what the object depends upon if we remove that dependency, then maybe the object will not work as well. Let's see. X, comma, Y. Oh, those are just individual variables. And backwards, E. That's the existential quantifier. That means at least one existential quantifier, at least one. Okay. And then the parentheses empty. That means universal quantifier. For all this, that is so. That's interesting. That's perhaps a placeholder, I would call it, like saying that we're going to allow what whatever you can think of, and we'll allow you to put it there and see what happens with the rest of the equation. See if it works, or find out where it doesn't work. Tx, that's a definite description. The x such that. Oh no, that's not tx. That's called 1x. Mm. Uh, well, let's allow you to take a screenshot of the rest of the page. So I got to 1x. The x such that. And I'll leave it at that. And we'll get back another time to look at this book. So I hope you enjoyed this thoroughly. You you probably need a break. Well, as you can tell, I need a break. So thank you for watching. May this benefit all sentient beings and all beings who want to wake up and think logically, or think about logics philosophically. Thank you. Thank you, Susan.